Hello and welcome. In this video, we'll be discussing how we do post hoc tests using R. So I'm going to start out with my data set in the data frame. This is the wide form. I'm going to load tidy R and then do my long form conversion. I'm also going to have the built-in test to calculate the model, and this is what I'm going to use for the built-in post hoc test when we get to that stage. Last, I'm going to load some specific information that I was using for hand calculations that I'll use for the hand calculations of the LSD. Specifically, I'll need the number of groups, capital I, the number of observations in each group, capital J, and I'll note, remember, capital J is also called lowercase n, and so in your notes, you'll see lowercase n instead of capital J. You can change that out if you prefer in some places. I'll see that in your notes. I'll need the group variances just so I can calculate the SSE pretty straightforward by taking the sum of those group variances. I'll need the degrees of freedom for the error, and then I'll need the MSE. Now I'll note quickly, you can find the MSE if you want to, the SSE and the DFE if you wanted to find all of those pieces just by looking at the summary of your model. So real quick, I'll run all of this. I'll just look at the SSE, DFE, and MSE, and then if I do the summary of my ANOVA model, show that the SSE is available here, the DFE is available here, and the mean squared error is available there. Mean squared error also has its own command, sigma model, and then squared, and that pulls the MSE straight from your ANOVA model with the built-in test. All right, so going on as to how I build this LSE with by hand. Well, it's actually really straightforward. I only need one more piece of information. I just need the critical T value, because remember, the LSD is looking at two sample t-tests, pairwise tests between each of the groups. So for my T critical value, remember that I'm going to be using alpha over 2, so I have 0.05 is going to be my alpha over 2. If you're using a different alpha, of course, you'd put in a different number instead of 0.05 there. Also remember, I'm using the mean squared error and the degrees of freedom error for my components instead of the regular components in the t-test. So in a normal two samples t-test, I would be looking at the Satterweight approximation to determine the appropriate number of degrees of freedom. But in this case, I use the degrees of freedom from the error term from my ANOVA, or if you're using the other notation, degrees of freedom within. As before, I like using lower tail equals false, and in this case, we do only pull the upper tail version for the building of the LSD. So I'm going to keep that lower tail equals false and just stick with the positive number here. All right, so I have that saved as T, and now I have everything that I need. That was the last piece of new information. Again, all this we calculated in previous videos. It's the last piece of new information I needed to calculate my LSD. So my LSD is my T critical value times the square root of the MSE, and I mentioned we're going to use that MSE here, times 1 over capital J. In your notes, this is 1 over n, lowercase n, plus 1 over capital J. And remember, if our groups were different sizes, I would use the different numbers for each group comparison here. But because my groups are the same size, I can just use 5 here. But if one group was 5 and one group was 3, I'd have to put these in as 1 divided by the sample size of the first group, 1 divided by the sample size of the second group, and I'd have to recalculate this value for each one. So this is LSD, and again, it's the same LSD for all my group comparisons, though if the groups are the same or different sizes, I'd have to kind of copy and paste and recalculate this for each of the different group sizes. But for me, yeah, that's the LSD. That's all I need to find. So I would then take my group mean comparisons. So I'd look at my group means. So BAT-DAT, it's my wide data set, look at the columns and find the means for each column. And I'd subtract each of these means, 70.8 times 80.3 or 80.6, 70.8 times 70.2, and then 80.6 minus 70.2 to find all of my pairwise means and compare each of those to the LSD. Any differences that are bigger than the LSD are significant. Any differences that are smaller than the LSD are not significant. Remember, when I do the difference, I don't care which number is bigger, so I don't look at the positive or negative sign. In fact, we take the absolute value. Absolute value is really easy to do by hand. You just ignore the sign, positive or negative. If you want to do it using a function, though, the function in R is ABS. And if I give it a negative number, it just ignores that and uses the positive number. So you can do that if you want to. Again, it's really easy to do by hand, though, if you prefer. All right, so that's calculating the LSD. That's kind of it. Let's talk about doing the pairwise comparisons using some built-in functions. So for the built-in tests, I'm going to need a new package. I'll do install.packages. And I'm going to be using the desk tools, DESCTOOLS, with a capital D and a capital T. So I'm going to go on and install that. Remember, I only have to install it once per computer. After that's installed, I'll comment it out, and then I'll do the library command to tell R, yes, I actually want to use it right now. You'd think R would know if I just installed it, I want to use it right now. But sometimes it doesn't. So this says, yeah, go on and load up desk tools so I can use the functions from within it. Specifically, the function I wanted access to is the post hoc test function with a capital P, capital H, and capital T. What I give the post hoc test function is my model, and then the method that I want it to use for the post hoc test. So remember, the one we just did by hand was LSD, but we talked about a couple others, and we'll show how we run those in R in just a second. For the LSD, you'll see the group comparisons, say, between E and D would do the difference. And actually, it shows you the difference direction that it does. It does E minus D, so 80.6 minus 70.8. And then it gives you the size of the difference, the confidence interval for the difference, and the p-value of that difference according to the Fisher's LSD method, which, again, doesn't make any corrections for multiple comparisons. And it's a bit liberal, but it's an easy one to do in class. Now, I will mention that though this is using the LSD method, this does not provide the LSD statistic that is the least significant difference. So because of that, you may or may not, depending on the homework problem, want to or be able to use this. With that said, in a practical situation, this is extraordinarily useful because I have the confidence intervals for each of the comparisons and I can report that. I believe in our lecture notes, we do show how we report that in the APA format, and I have the p-values, which is enough for me to make decisions on the significance of any comparison. E minus D and, E and D and E and G are both significantly different, with E being bigger than both of those. And again, how do I know E's bigger? Well, I could look at the differences and kind of do the mental math. Okay, negative here means that the second number, E, is bigger. Or I can just go up here and say, okay, E and G are different. Which one's bigger between E and G? Well, E is the bigger number when comparing E and G. So E is significantly bigger. All right, well, I'm going to copy and paste this line and then change the method. So I mentioned LSD is easy to do by hand. It's why we do it in class. But really the better method, if you have an option, is Tukey's HSD. So how do I do the HSD? Well, I change the method from LSD to HSD. You'll see up here the post hoc comparison now uses Tukey's HSD as opposed to Fisher's LSD. My differences stay the same, but my confidence intervals and p-values change slightly. This is expected. We're using a different adjustment method. The LSD didn't adjust at all for the increased error rate. The HSD does make an accurate adjustment for pairwise comparisons in the error rate, and our p-values and confidence intervals reflect that new updated adjustment. While Fisher's LSD is a little bit liberal, Tukey's HSD is pretty accurate. I'll mention we discussed a third method, and that can be implemented again by changing alpha, but that can also be implemented on the software side. We talked about the Bonferroni correction, or the Bonferroni method. This method, as opposed to changing alpha, goes ahead and changes your p-values for you so you can keep using the same alpha. So let's say we had to do alpha over 3 to account for this. This goes ahead and multiplies each of your p-values by 3 so that you can compare to the same alpha. It's a different way of approaching the same thing. Note that the confidence intervals have also been adjusted using the Bonferroni method in the post-hoc test command in R, and that's handy so that you can, again, have confidence intervals that have been updated and are now corrected. As we discussed in the lecture notes, LSD is a little bit liberal. That is, if you use these values, you're going to have a type 1 error rate, accidentally saying something significantly different when it's not, a little bit more often on average. Bonferroni's a little bit conservative. You're going to not have a type 1 error rate as much as you say you are, but that means you're going to miss some opportunities. HSD tends to be closer to right on when you're doing these pairwise comparisons. All right, well, this was a pretty short video, but it's a pretty short and concise concept. And again, we'd already done a lot of the main work in our previous videos. In this video, we discussed how we can do post-hoc comparisons in R. We discussed the creation of the LSD statistic and how we can use the previous analyses and results that we had to make the LSD statistic pretty easily using those results, as well as how we do those comparisons. We also discussed how we can use built-in tools from the desk tools package, such as the post-hoc command, to run our post-hoc comparisons. While this didn't give us the LSD statistic, this did perform our analyses. It gave us confidence intervals, and it gave us p-values for each of the comparisons so that we could pretty quickly and easily determine which comparisons were significantly different. All right, team. Well, thanks for sticking with me through this video, and I'll look forward to catching you in the next one.